Hey guys, happy Friday. I have for you your lesson today. If you missed live class, we have our final test for the chemical reactions conservation of mass unit. We're going to do some slides to get you warmed up, and then we're going to go into your final test. So starting with this do now. Here you have a chemical equation. This was a similar question. This is the same chemical equation rather. As your exit ticket, but there's a problem with this equation, guys. Excuse me. There's a problem here. What is the problem? I like the pointer thing. So you might want to take some pencil and paper real quick and scribble down the reactants and products, how many atoms of each element there are down here, just like we worked on in class yesterday. That way you can kind of compare them maybe. But I want to know what's the problem here. So once you find it, describe for me the problem. Okay, and I'm going to keep going, so you go ahead and pause and do that. It will help you practice for your test, I promise. After I tell you about the sciences of the day, we're going to move into breakout rooms, or else I'll show you the practice test that you can take. And then we're going to do some independent work, practice slides, and your final test. All right, this is Miss Eva DeBong. You might be thinking, oh, she's quite the youngster. She's only 22 this year. She is a student at a polytechnic school in New York, and it's her last year. She's in her fourth year. She has a double major. So she studies design, innovation, and society, and also mechanical engineering. When she was younger, she didn't think she'd end up in STEM, science, technology, engineering, and math. Because of this misconception, these are her words too, misconception that engineers look a certain way and that all they care about is math and science, and that's not what she cares about. She is interested in what she calls the intersection, like where design and engineering meets social justice. And I love this answer. So that's kind of this mechanical engineering. She's learning how to like build bridges and that kind of engineering, but also how does that design fit with innovation, with society, about where in society do we need engineering, etc. She's also working on her private pilot's license. And I like this quote. I'll come up here. This quote is, ultimately, I aspire to use my engineering background to make the world a better place. I love this so much about her. And I'll tell you a little secret about Miss Eva DeBong. When she was in middle school, when she was in 8th grade and then again in 9th grade, she had a very fantastic science teacher, this guy. This is a former student of mine, and I'm so proud of her. I taught her when I lived in West Africa. She's actually Cameroonian. Her mother was the French teacher at the school I worked at, and now she's in New York. She's about to graduate with this amazing degree. I'm so proud of her. So maybe one day I would be honored to put one of you up on my Sciences of the Day, or maybe all of you, if you go on to do great things and to make us proud in that way. Okay, so here's our rubric for today. So yesterday we really focused on identifying number of atoms in reactants and products. We're going to do a little bit more. We actually have done a little bit more modeling. We practiced this a little bit yesterday. We'll do some more of this. And in your practice assessment, you will have an opportunity to, and actually you're due now, you will have an opportunity to show that mass is conserved in a chemical reaction. Okay, so before I go down to the breakout rooms, I do want to go back to the do now. I hope, and I'll just go ahead and fill this in for you real fast. How about that? Here we go. Iron is Fe, and oxygen is O. You guys know that. I'll just make these bigger. There we go. Eesh. Copy, paste. All right. If you look over here, there's 4 and 6. 3 times 2 is 6. 4 times 1 is 4. Okay. And over here, there is 2 and 3. What's the problem with this chemical equation? The problem is that it's not balanced, is the words we use. There are not the same number of atoms on both sides. Now, I'm not a wizard. I did not make these atoms disappear. All I did is I forgot to put a 2 up front here. Because if you react 4 of these with 3 of these, you don't get 1 iron oxide, which is just rust. By the way, this is the chemical equation when rust forms, like on your car or on a bicycle. Four iron atoms and 3 oxygen molecules don't make 1. They make 2 molecules of iron oxide or rust. And now these numbers will work. That's the problem with that. So let's continue on. For your breakout room, you guys are going to take this practice test. It'll link to here. Use extension icon. Oh, how do I do that? Like this. Or this tab. Yeah, I think it's working. Okay, so now I'm recording a different tab. So this is your practice assessment. I'm going to read it out to you, okay? So this is all practice, so do make mistakes here. Go back and look at your answers. Go, oh, that's what that meant? Okay, now I get it. And then when you take the final test, you'll get it right. So 2 mg plus O2 changes into 2 MgO. You've seen this. You've modeled it. You counted the atoms. Now, which statements are true? There are 2 molecules in the reactants, 2 in the products, 3 molecules in the reactants, 3 in the products. Which of these are true? Maybe more than one. Maybe all of them are true. If you want, you can click on all of them. You can click on some of them, etc. How many oxygen atoms are in the reactants? How many are in the products? What happens to the atoms of a reaction during a chemical reaction? Which of these answers that correctly? So you're going to answer all of these questions. When you come all the way down to the bottom, your job is to figure out how to balance this equation. You're going to choose one of these numbers. How many? So right now this is not balanced. One of these does not make one of these and one of these. If you did, you'd have 2 H's, 1 O, 2 O's, and 2 H's. Oh, okay, so that's a problem. So how are you going to balance? What number do you need for H2O? What number for O2? What number for H2? For each row, you're only going to choose one number. That's how you're going to get it right. Okay, let's go back. And I have to click again the thing. Let's see if I'm doing this right. Record this tab. And I think I'm back. I don't see my face anymore, but let's just hope that you guys are still with me. Okay, so for your independent work, I just have 3 kind of more practice slides and then your test. I just want to make sure you're really warmed up because I really want you to do well on this test. I know you guys can do this. Here is a model. Make sure you're looking at 2 and 3 and 2 and 3 and 2 molecules. Use the atoms below to model this. Practice counting the elements here. And then there's a mistake in this model. I blew it. This is correct, but the model isn't. Tell me what the mistake is. And after you answered those 3 slides, you're ready for your test, guys. Open this up and take it. It'll look just like the practice test. By the way, last chance today. If on Monday you missed Monday or you didn't like the score you got, use this reassessment to reassess on PS11. You guys can definitely do well. We've been practicing this for a long time. You guys got it. Go do it. I'll see you next week on Monday. Have a good weekend.